All right, so if you were absent from math today, this video is for you. We're going to get started on our next unit. Excuse me. Unit 6, equations. Equations. And so what we're going to do is just kind of set up the cover of our packet here. We're just going to write our name. I'm just going to write my name. So write your name on the first line. Our base is Andromeda. Andromeda. Homeroom. Right at whatever your homeroom is. Mine's 170, but whatever your homeroom is, just in case you lose it, we'll be able to get it back to you. All right. All right, equations. Now, you can almost see the word equal in equations. So the big difference between an equation and an expression, expressions didn't have any equal signs. Equations do. An expression is almost like one side of an equation. So what we're going to do today is just kind of take almost like a sneak peek at what the unit is going to look like. And we're going to learn or, see some new things that maybe we haven't done before. And I just want to emphasize that this unit is not really about the answer. This unit is about learning how to write and solve equations and check them. So if you open up to the page 2 and 3, you'll see there's vocab here that might be helpful during the unit. But we're going to go to page 4. And we're going to do a little bit of an introduction today. I'm going to show you how to solve and check an equation, and also how to set up an equation as well. So let's start it off here. We're on top of page 4. It says Maddie made 8 cookies in the morning and some more in the afternoon. Well, we don't know how many that is that she made in the afternoon. After all her baking, she had 14 cookies. How many did she bake in the afternoon? Well, we don't know how many she baked in the afternoon, but this equation is going to help us find that number. This would be called an addition equation. X plus 8 equals 14. X is what we don't know. That's how many she baked in the afternoon. So we're going to let X, we got to write the let statement, let X equal number of cookies baked in the afternoon. Whoop. So this addition equation is going to be, well, here's the afternoon cookies. We don't know it yet. Plus the ones she cooked in the morning, that total is 14. So I'm going to show you how we're going to find that 14. What we want to do is called isolating the variable. We want to find out what this X is, and we want to get it by itself. Right now, there's a plus 8 with the X. We want to somehow get rid of that plus 8. And so what we're thinking is, well, how can we do plus 8? What is the inverse or the opposite of plus 8? And that would be minus 8. But here's the thing. If I subtract 8 from this side, since both sides are equal and I want them to stay equal, I would have to subtract 8 from the other side too. So what I'm going to do, and this is just something I like to do just to set myself up, I'm going to draw a line right through the equal sign. Because that line is going to remind me that this side, x plus 8, is the same thing as this side, 14. And I'm going to use the inverse of addition, which is subtraction. And I'm going to subtract 8 from both sides. Then I'm going to draw a line here just to kind of be like my sort of like equal sign at the end of the operation. Plus 8 and minus 8. Plus 8 and minus 8. That's 0. So I'm just going to cross those out. Those kind of cancel each other out. And all we're left with is the x, which is what we wanted. We want the x to be by itself. And the x equals, well, whatever 14 minus 8 is. And that's 6. So this is the solution. In this problem, x would equal 6. And to check that, what we're going to do, we're going to check these the same way each time. The first thing we're going to do when we check it is we're just going to write the equation down. Now, in this equation, we found out that, in fact, x was 6. She made 6 cookies in the afternoon. So 6 plus 8 equals 14. And then to check it, I'm going to do, well, I can do the math here. 6 plus 8 is 14. That equals 14. That checks. So the check is just making sure that the number I found out, which was 6, was actually the right number. So to answer the question, how many did she bake in the afternoon? The answer, which we'll write kind of on the bottom here, is Maddie baked 6 cookies in the afternoon. Now you might be saying like, oh, well, I could have just found that answer out right away. Like I didn't have to use an equation. Yeah, you probably didn't need to. However, this unit is about how to write and solve and check equations. So yeah, you could get the answer really quickly, but that's not really what the whole unit is about. So I understand when you'd say like, oh, I can get 6 right away, but remember the unit is about writing and solving equations, not just finding the answer. Now let's check out another one. Helen started the day with a number of jelly beans. Oh, we don't know how many she had. She ate 12 jelly beans throughout the day. By the end of the day, she had 4 jelly beans. How many jelly beans did Helen start the day with? That's the number we're trying to find out. So this equation is going to help us find that. She started with a certain number of jelly beans. She ate 12 minus 12, and she wound up with 4. So we're going to let x equal number of jelly beans Helen started with. That's the number we don't know now. Yeah, you could probably figure it out pretty easily, but again, we're going to practice solving and checking the equation here. All right. Well, she started with a certain number. She ate 12. That's where the minus 12 comes in. That equals 4. Now, I'm going to just draw that line here again. That just shows like we have 2 sides of the equation, x minus 12 and 4, and they have the same value. We just have to find out what that x is. We want to get the x by itself. It's called isolating the variable. So to get rid of the minus 12, we have to do the inverse or the opposite. Well, what's the opposite of minus 12? The inverse would be plus 12. So we're going to add 12 to both sides. Okay, all right. So on this side here, we have a minus 12 and a plus 12. What happens is that those equal 0 and they cancel out. Those just go away. That's what we wanted because we want x by itself. And then on this side, we add 12 and 4. Well, what's 12 plus 4? That would be 16. So now we just solved the equation. We found out what x is equal to. X was the number of jelly beans she started with. She started with 16. So when we check it, again, we're going to check it the same way each time. We're going to write the equation that we started with. The next step is instead of x, we're going to write what we found x to be, and that was 16. Minus 12 equals 4. All right, and then we can, on this side, we can do 16 minus 12, which is 4. That means that the 16, which is our answer, the number we got when we solved it, that 16 is definitely correct because 4 is equal to 4. So how many jelly beans did she start the day with? That's the answer. Helen started the day with 16 jelly beans. All right. So again, this would be our answer, and this just checked to make sure that the answer we got was correct. All right, let's see this next one here. It says, at a basketball camp, there were 5 teams and 35 total campers. Each team had the same amount of campers. How many campers were there on a team? Well, that's the number we don't know. So we'll and again, we see this is the equation here. There are 5 teams or 5 groups. Each team had the same number of players, and in total they had 35. Now you probably know what the answer is already, but again, we're just practicing setting up and solving the equation. Again, the focus is not the answer. It's can we solve an equation? Can we check it? So we're going to let x equal the number we don't know, which is number of campers per team. Number of campers per team. All right, now this one's a little different because, again, we want to draw that line right through the equal sign. We want to get the x by itself. This is going to look slightly different than the other two. Well, we got to think, how are we going to get the x by itself? Right now there's a 5 times x. We're multiplying by 5. So we want to get rid of the multiplying by 5. We want to do the opposite. We want to do the inverse. The opposite of multiply by 5 is to divide by 5. But here, we're not going to necessarily see the division symbol. We're going to use a fraction because fractions are kind of like dividing too. So we're going to divide this side by 5, and we're going to divide this side by 5. So we're going to show division like a fraction here. Now, again, we want to get the x by itself because when we get the x by itself, when we isolate it, we find the answer. Well, 5 divided by 5 is just 1. So what happens here is these 5s cancel each other out. And you're just left with x. That's what we wanted. We wanted to undo the times 5, so we divided by 5. On this side, we have 35 divided by 5, which is 7. So that means that there are 7 players or 7 campers on each team. Well, let's just check to make sure that that's right. It feels right. It seems right, but let's just check it. So 5x equals 35. We'll start by just writing out the equation. Now, I'm going to put a dot in here because that's like 5 times x. All right. So instead of 5 times x, we'll do 5 times, and we got x is 7, so we'll put a 7 in there. Well, now we can do the math on this side. 5 times 7 is 35, which is 35. So the answer, the answer is this. That was the solution, also called the answer. Solution, answer, kind of the same thing. How many campers were on each team? Well, there were 7 campers per team. Now, again, this is just an overview of the unit. The rest, for the remainder of the week and when we come back from break, we're going to be looking at each one of these individually. Like we're going to be looking at addition equations and then subtraction equations and then multiplication. So we're seeing them all at once just to kind of see what equations and checking equations looks like, solving and checking looks like. And then we're going to focus on each one individually to get a better sense of how to write one and how to solve one and how to check one. All right, so let's check out this last one on this page. It says, someone brought in some teddygrams to a pre-K class. It sounds like a great person. Each preschooler got 6 teddygrams. There were 12 preschoolers. How many total teddygrams did the preschoolers have? So how many did they get? We don't know how many they got, but this is a division equation. We don't know how many they got, but if we divide how many they had to start with by 12, because there were 12 preschoolers, each person got 6. So we need to find like the total amount they have. So how many total teddygrams did the preschoolers have? We're going to let x, because that's, again, the variable that was used here. We're going to let x equal number of total teddygrams, a pre-K snack enjoyed by all. Haven't had one in a while, but I sure do miss them. All right. So x is the total number. Now, just like we did the last time, I'm just going to draw a line right through the parentheses. It's going to remind us that each side, we have to do the same thing to each side, and each side is equal. So here's the thing. I have a divide by 12. I have a divide by 12. So what we want to do is get rid of the divide by 12. We want to do the opposite, the inverse. Well, what's the opposite of divide by 12? What's the inverse? The inverse would be to multiply by 12. Now this one's going to, again, look a little different, but we're going to multiply both sides by 12. I'm going to do it like that. I'm going to kind of do it side to side like this. I'm going to multiply this side by 12. Notice I use the dot. And I'm going to multiply this side by 12. And again, these sides are still equal because I multiplied them both by the same thing. So what happens is these 12s here, they cancel out. That's what we wanted to happen. We want to get the x by itself. Multiply by 12 and then divide by 12. Those cancel each other out. And so what you're left with is x equals, well, what's 6 times 12? 6 times 10 is 60. 6 times 2 is 12. So that'd be 72. So that means they started out with 72 Teddy Grahams. They shared them with 12 people. Each person got 6. Let's just check to make sure that that's the right solution here. So again, first thing we're going to do, we're going to write the equation we started with, which was x divided by 12 equals 6. Then we're going to check to see if that number 72, which we got earlier, if that is actually the answer, in fact. All right, so we're going to put 72 in for x. Well, how many times does 12 go into 72? Well, again, 12 times 5 is 60. That's 5 12s. You can put one more 12 in there. So 72 divided by 12 is 6. That checks out. The reason we do the checklist, let's say I got 24. If I got 24 for some reason, 24 divided by 12 is 2, and 2 is not equal to 6. So this step is really important, and it kind of again, it's a check. It's checking to make sure that we got the right answer. All right, so how many total Teddy Grahams? The pre-K, lights went out, had 72 total Teddy Grahams. So those are the different types of equations that we're going to look at. We're going to look at equations that involve addition, subtraction, multiplication, and division. So again, this was just a preview. We're going to try a couple more here, but I hope you saw sort of a pattern for each one of these. One thing we did for each one is we kind of separated the two halves that are equal to each other with a line. The other thing we did for each one is we used the inverse operation, the opposite operation, to get rid of the number next to the variable. To get rid of plus 8, we subtracted 8. To get rid of subtract 12, we added 12. To get rid of times 5, we divided by 5. To get rid of divide by 12, we multiplied by 12. We did the same thing to each side because we want to keep it equal. And then for each one, we checked it sort of in the same way. We wrote the equation, we put in our solution, and we saw and actually checked to make sure that it was correct. All right, so we're just going to try a couple more here. And for these ones, I'm actually going to help you write the equation because we had the equations in the last one. Let's see if we can try to write a couple here. The Bills had 21 points in the first half. Go Bills. They scored 36 points in total during the game. How many points did the Bills score in the second half? That's what we're trying to find. So we can pick a variable. P equal, I'm just going to adjust the pencil here. Number of points Bills scored in second half. Now, the hard part about this is thinking, well, what type of equation are we going to use? Well, I like to start out just by writing the variable, P. Okay? All right, so the Bills had 21 first half points. In total, they scored 36. So this is the second half. If we add to it the first half, whatever P is, if we add the total in the first half, we should get the total number of points. So whatever they had in the second half plus whatever they had in the first half is going to equal 36. That's going to be our equation. This equation is going to help us find what P is, which is the number of points they scored in the second half. So we're going to kind of do the same thing we did on the previous problems. We're going to draw a line right down not the middle, but between the equal sign just to separate our parts. Two parts of this equation, P plus 21 and 36. They're both equal. But we want to get that P by itself. We want to isolate it. So we're going we're going to do the opposite of plus 21. We're going to subtract 21 from both sides. We have to do it to both sides to keep them both even, to keep them both equal. So on this side, plus 21 minus 21, those cancel each other out. Those equal 0. Those vanish. Those go away. And what we're left with is p, which is what we want to be by itself, because we want to figure out what number that is. And then we subtract. 6 minus 1 is 5. 3 minus 2 is 1. That means the Bills scored 15 points in the second half. Well, let's just check to see if that's true. So do p plus 21. The first thing is we'll write the equation. Then we'll put the 15 in, because that's the answer, the solution we got. 21 plus 15. Well, 1 plus 5, that's 6 ones. 2 plus 1 is 3 tens. That checks out. So that means the Bills, go Bills, scored 15 points in the second half. All right. We're going to try one more here. One more. There were 42 kids in a gym class. Okay. The teacher wanted to make 6 equal teams to play handball. How many players were in each team? Well, that's what we're looking for. How many players were on each team? So I'm going to let T, I guess, equal number of players per team. All right? So that's T. That's T. So to write the equation, well, if we take the number of players on a team and we multiply it by 6, we're going to get the total number of kids in the gym class. So this is going to be a multiplication equation. 6 equal teams times the number of kids per team would equal 42. Now, like let's say there were 5 kids per team. Well, that wouldn't make sense because 6 times 5 would only equal 30. We want to get to 42. So to figure that out, first I'm going to divide my sides. How do we undo or get rid of the times 6? Well, we do the inverse, the opposite. We're going to divide by 6 on both sides. We're going to do the same thing to both sides to keep it equal. The 6's cancel out. They go. They are done. We're left with only t, which is what we want. And then 42 divided by 6 would be 7. Okay, let's check to make sure that that's right. So to check it, again, we start with the equation that we started with. 6 times t equals 42. Instead of t, though, we're going to put what we got in the second row. 6 times 7 equals 42. Well, what's 6 times 7? That is 42. So that means that the answer we got, 7, is absolutely right. Okay, so that means there were 7 players per team. So every team had 7 players. All right, so that's just a preview of equations. I hope that you started to see some connections, started to see some patterns. If you have any questions, let me know, and I hope you have a great day. All right, bye-bye.